Hi students, here we're going to be looking at some complex expressions that's dealing with numbers that involve the imaginary number and how to work with them. All right, first we've got something that involves powers of I, and I want to take a minute to remind us what I is. We had an issue in studying algebra when we had things like the square root of negative 16. The square root of negative 16, we can't come up with a number that would show up on a graph. 4 is the square root of positive 16, but negative 4 times negative 4 also gives you positive 16. So the way that we worked with this was we rewrote this as the square root of 16 times the square root of negative 1. That let us write this as 4, and instead of writing the square root of negative 1 every time, we use the symbol I. I is the square root of negative 1. We call this the imaginary number, but it would be better called an invisible number because it just doesn't show up on a graph. It's not a make-believe number or anything. It's a number that actually exists. One of the cool things about I is that you can do some interesting things with it in terms of powers. So if we square it, well, that would be the square root of negative 1 squared, which is negative 1. If we cube it, well, that's squared and then times another 1, so we have negative 1 for the squared part, times I. I to the fourth power is going to be negative 1, and that's going to be I squared, so times negative 1 gives us positive 1. And you might imagine that if we then multiplied by another I, we end up with positive 1, which is the fourth power, times another I, which is I. So what happens here is that we end up in cycles of I, where every 4 powers we kind of go back to the beginning again. The first thing I'm going to do, if I see I to the 30 times I to the 20 times I to the 29 times I to the 6th, is I'm going to combine my exponents as best I can. 30 plus 20 is going to be 50. Plus 29 is going to be 79. Plus 6 is going to be, we said 79, so 85. And since a power of 4 gave us 1, if we can figure out how many would be left over in this after we get rid of all powers of 4, we would end up with just that number of i's left. Okay, I know that 80 divided by 4 is 20. Cool. I know that 84 divided by 4 also works. That's 21. And that would be something like saying I to the 84 times I to the 1. Since 84 is a multiple of 4, I to the 84 is just the number 1. That's what we got out of this operation over here. Every 4 powers of I, we end up canceling everything out and going back to 1. I to the 1 is just I. Our answer to this problem is just I itself, which seems really weird given how large that power was. The second thing we need to be able to think about with regards to I is one of the easier things that we do because it behaves the way we'd like it to. In this form, these complex numbers that have both a real and an imaginary part can be combined through basic operations. What we're really doing here is combining some like terms. So we have 12 plus negative 1, okay? That's positive 11. And then negative I plus negative 8i is minus 9i. At this point, we're done. We've combined our real parts and our imaginary parts of these complex numbers to make a new one. We can also deal with this in terms of multiplication. The trick here, in fact the hardest part, is remembering that I squared is always equal to negative 1 because I is defined as the square root of negative 1. So when we multiply things out, negative 11 times 2 is negative 22. Negative 11 times 6 is minus 66i. And then we're going to have negative 7i times 2 minus 14i And negative 7i times 6 is minus 42i squared. And here's where this comes in. Because I squared is the same as negative 1. This is really plus 42. I'm going to combine my other like terms and leave the negative 22 alone. Minus 66 minus 14 is minus 80i. Combine negative 22 and positive 42, we get positive 20 minus 80i. And that's it.